What's up everybody, welcome yet again to CPDict. In this video we are going to look at the problem B from today's Codeforces Global Round 11. The problem is called Chess Cheater. So we like playing chess tournaments online. We play N games. For the sake of this game, each game is either won or lost. There are no draws. When we lose a game, we get 0 points, and when we win, we either get 1 point or 2 points. If we have also won the previous game, only then we'll be getting 2 points. Otherwise, if we are winning the first game, that is either it is the first game or the previous game was we did not win the previous game, then we'll get 1 point by winning the current game. Now the outcome of n games are represented by a string s of length n. It is w if we win that game, and it would be l if we lose that particular game. After the tournament, we noticed some bug which allows a user to make at most k changes, such that he can change w to l or l to w. The guy or we perhaps want to cheat and we want to maximize our score. So yes, these are the constraints. Let's see what we can do to solve this problem. As we want to maximize our score, so we want to change as much L's into W's, the appropriate type of W's. Let's see what I'm talking about. Let's say I'm having an array of or string perhaps, which looks something like this. Like there is some consecutive range of L, then there is some consecutive range of W's, and at the end I'm having some L's. Okay, now the answer, first of all we will calculate our score, the score which we would be getting if we do not make any changes. So if you see, if we calculate the score, if we have a consecutive string of W's of length m, then the score we would be getting from this would be equal to 2m minus 1, or you can say 2 into m minus 1 plus 1, because in the first game which we win, we would be getting 1 point, and for the other two games we would be getting 2 more points. So the formula would be 2m minus 1, or you can say 2 into m minus 1 plus 1. So first of all, we calculate the score for each of these consecutive values. So at this point we have found out the score corresponding to these batches. Now I am categorizing these L's into different categories. If I am having a W on both the sides of a particular range of L's, this I am having multiple L's here, but I am also having W's on both of its sides. Let's say I'm calling it as a batch because I use this term in my code. So I'm having two batches in this particular string which are of length 3. Now let's see, if we are changing these L's into L, if I change this L into W, then I'll be getting 2 more points. As the previous game we have already won, similar to we will get 2 from this, and if we modify the last L of this batch, we'll get 2 from this also. If you see, initially when we were calculating the initial score, we added 1 from the 1 corresponding to this W, but now as the previous game we have changed this L into W, the previous game is also, in the previous game we are also winning. Now we also add plus 1 to this W because the previous game is now on the winning cause. Similarly, it is exactly same. We'd be adding 2 more here, 2 more here, 2 to this and 1 to this. So if for this batch, suppose I'm having a batch of length m, so I would be adding 2 into m plus 1 to my score. This is for the batch where a consecutive L's when I'm having W on both of its sides. If I'm having m L's in such batch, then if I change all L's into W's, then I would be adding 2 into m plus 1 to my score. But if suppose the batch is of length m, but I can change only let's say m1 else, because the k is less than m, or you can say m1 is less than m. Let's say yes, I can only change k strings and k characters, and k is less than m. In that case, I would be adding 2 into k to my answer. Then in that case I won't be adding, or I won't be changing the last L into W, and if I do not change the last L, then I would be getting 2 from each of those chars. I only get the plus 1 when I'm also changing the last L of my batch. So if in the batch case, if k is less than m, then I would be adding 2 into k, but if I'm changing the whole batch, I would be adding 2 into m plus 1. Now these are for the cases when I'm having W on both of its sides. But let's see the other cases when I'm having a consecutive set of character L in the beginning itself and at the end itself, like only at one side. I'm having a W only at one side, not on both the sides, on to the consecutive set of L's. In that case, suppose I'm talking about this case, then I want to change, suppose I want to change one L into W such that my score would be maximized. If I change this L into W, I would only be getting plus 1. Similarly, if I change this L, I will only be getting plus 1. But if I change this L, I would be getting plus 1 from this. Also, I would be adding plus 1 to this W, because now this W is not the first game which you are winning on a continuous basis, because as we have changed this L into W, now there is a game previous to this current W which we won. So now we would be adding plus 2, but initially when we were calculating the initial score, as I explained, I added 1 to it. So whenever I'm changing a consecutive set of L's, and when I'm only having I'm having W only at one of its ends, then I would change it. I would start changing the L's which are near to the W. First I will change this L, then this L, then this L, because let's see step by step. If I change this L, I would be getting plus 1 from this, and I would be getting plus 1 to that. Similarly, if I then after that I change this L into W, I would be getting plus 1 for this, as this is the first game. Also now I would be adding plus 1 to this W, as it was previously changed to W, of course, but at that moment this is the first game which we are winning continuously. But now I have added another W just left to it. Now I would be adding plus 1 to it. And similarly to the case when am having a set of consecutive L's at the end, I will start changing L's into W's which are near to W. So I'll change this L into W, then I'll be getting plus 2, because I have won a game previously to this current game. And when I want to change another L into W, then I'll change this. I will be plus 2, similarly plus 2. So if I'm talking about the starting set, I called it as start. I'll keep changing the L's into W's from right to left. Also, if you see, if I have changed 3 W's, then I would be adding 2 into 3 my score, 2 into 3 to my score, because if you see, if I change this, I'm getting plus 1 plus 1. Similarly, if I change, I would be plus 1 plus 1. So even in this case, if I change M L's into W's, then I would be adding 2 into M to my score. And similarly at the end, I called this portion as last in my code. So if I change M L's into W's in this portion, again I would be adding 2 into M to my score. Now I have 3 types of sets. The first batch which I talked about, and here the last one. Now it can have multiple ranges, so I stored it in a vector. But whenever I'm changing a batch, I called a set of consecutive L's as batch when I'm having a W on both of its sides. So if I change all the L's into W's of a batch, and suppose there are M L's in a particular batch, then I would be getting 2 into M plus 1, I would be adding this term to my score. And if I change mLs into Ws to the last section which I had explained, then I would be adding 2 into m to my score. Similarly here, if I change mLs, I would be adding 2 into m to my score. Now if you see, we are getting more benefit if we change a whole batch of L's into W's. But it is only when we are changing the complete batch. If the batch is of size m and I'm changing only KLs and k is less than m, in that case I would be adding 2 into m to my score. So as we want to maximize our final score, first of all I try to cover up as much batches as we can. First of all, cover the batches, like whole batches, because in that case I would be adding 2m plus 1 to my answer. And if I see that I cannot cover a whole batch, I'll try to cover the part which I can. Suppose k is less than batch I, I'll change k else into kWs. And if I'm done with all these batches, still I'm left with some k, then I'll go to this last portion and then go to this first portion. If I still am left with some k, I can change, I can perform few more operations. Then I change this last I'll pick else from this section as well as from this section. Suppose I change x else by combining last and first section into m's, then I would be adding 2 into x to my answer. Now as we want to maximize these type of batches which we are covering whole, like which we are covering completely, like we are changing the complete batch of L's into W's, and we want to cover as much we can. So we will sort this batch vector first in increasing order so that we can cover as much batches as we can. For example, let's say I'm having a batch of size 3 and a batch of size 4, and the number of operations I can perform is 4. If I pick this 3 first, then I change all the L's from this batch, so I would be adding 3 into 2 plus 1. Then I'm left with one operation. I change one L from this batch of size 5, then I add 2 into 1. Now the answer comes out to be 7 plus 2, which is 9. But if I do it the other way around, like first I pick this batch of size 5 and I can only change 4 L's, then I would be adding 8 to my answer. So you can see 9 is greater than 8. We would be choosing the smaller size batch first, then we go on the bigger sizes. That's why we sorted this batch size, because it was giving us 2m plus 1 at that time. Let's see the code now. First of all, this is the final score which I will be getting. This is the first section which I was talking about in the explanation. This is the last section, and yes, there is one special case. Suppose we are having 0 W, that is we are only having all L's. We are only having L's in our string. We have lost all the games. Then we can convert at most KLs into W's, or if k is less than n, then we can only convert n else, obviously, because we can win at most n games. So in that case the answer would be minimum of k or n, whichever is the minimum, into 2 plus 1, into 2 minus 1, because we want to change else into W's on a consecutive manner. Suppose we have lost 5 games and this is the string which we have been given, and k is equal to 3, then we want to change first 3 W's, or these 3 W's should be consecutive. That's my point. So in that case the answer would be 2 into 3 minus 1, which is 5. This is the maximum we can have. We could have chosen this string, or we could have chosen this string as well. But if you see, if we choose something like this string, then the answer would be 1 1 1, which is 3, which is less than 5. Okay, it was the special case. Now this count L and count W, I'm using it to find out the sections which I was talking about. The first section, the size of my batch. That's why I've used these counts. First of all, the count is 0, count W and count else. It counts the number of W's I'm having in consecutive else I'm having in my current batch, and this is the consecutive W's I'm having in my current batch. Like this is a different batch which I'm talking about when I'm considering W's. Like I just want to find out the consecutive W's, and here I just want to find out the consecutive else. That's all. So I start my traversal. First of all, I see if the current character is L. I see if count W is greater than 0. If count W is greater than 0, it means the previous character must have been W. That's why we are having count W equals to greater than 0. Then we add 2 into count W minus 1 plus 1 to my answer that I was talking about initially. Like suppose I am having a consecutive set of 3 W's, then the answer would be 3 into 2 plus 1. That is what I have done here. And then I initialize this count W to 0 because now the current character is L. The set which the consecutive set we were getting initially of W's, now it is not going to continue anymore. Then I do count L plus as the current character is L. Similarly, at the other way around, if I see the current character is W, I see if first is equal to minus 1. I used it to find out the signs of the first set which I talked about. Like if there are some consecutive else in the beginning of my string, I use this part to find out the first. If first is equal to minus 1, it means I have not found out this L yet. So I initialize this first to count L, which is the number of consecutive L's at the beginning. Otherwise, if first is not equal to minus 1, it means I have already initialized it. If I see count L is greater than 0, it means the previous character must be in L. So I simply push it to my batch vector which I was talking about, and then I initialize count L to 0. And I also update this flag is equal to 1. This flag will tell me whether I am having at least one W in my string. It simply means I am having at least one W. Yes, at the end when I traverse the whole string, and then again I do the same. I check if count W or count L equal to is greater than 0, which I have done to this case. This is basically for the last section I am having. Now if I see if f equal to 0, it means we are having all else. We did not have even one W. So in that case, the answer would be minimum of k into n minus 1. If you see if k is also 0, this term will turn out to be minus 1. That's why I have taken maximum of 0 of my score. Otherwise, if f is equal to 1, it means we saw at least one W. So we sort the batches vector because we want to cover as much batches we can. So we start from the smaller size batch. We see now, then we traverse the batch, and if we see k is greater than or equal to batch I, that is we can convert this whole batch of L's into W's. So I add this 2 into batch I plus 1 to my answer, and I deduct batch I from k, as k is the number of characters we can change. As we have changed this much characters, we simply reduce or deduct this value. Otherwise, if we see that the value of k is less than batch I, then I just want to change these k else into W's, and I would be getting 2 into k adding to my answer. If after doing all this still I'm left with some k, that is I can perform few more operations, then I'll first change the last section, then I'll change the first section. That is the number of L's I'm having in the last section. I'll change all those L's into W's, and again here I'm changing all those L's into W's, and still if I'm left with some k, then I'll change the W's of L which are present in the first section into the L's which are present in the first section into W's as much we can. I've taken the minimum of it, that's why. If you see, if k is greater than or equal to last, so I only change last number of L's. Similarly here, if k is greater than or equal to first, I only change first L's into W's. At the end I'm printing out the answer. So this problem was all about changing this problem into the one which I had explained. Yes, there might be other better ways as well, but I converted it into this problem. The explanation turned out to be a pretty long one. I was not expecting it to be this big, but that's all for this video. I hope you liked it. If you learned something from it, please consider subscribing to our channel. Till then, take care. Sayonara.